In this section, we're going to look at IP subnetting. I'd like to teach you multiple methods for subnetting. Subnetting is one of those subjects that a lot of network engineers struggle with. But in this section, I'll hopefully be able to simplify it for you and give you various methods so that any subnetting question that you might encounter can be completed quickly and easily. There are two main parts in this section. In the first part, I'm going to show you two methods to quickly and easily answer questions like, what subnet is this host on? Or what is the last host in the subnet? So I'm going to teach you the binary method, and then I'm going to teach you what I call the quick method. I suggest that you look at both and then choose one and get good at that specific method. I think binary is very important to understand, but as the quick method name indicates, it's very quick and easy to answer subnetting questions using the quick method. In the second part, I'd like to show you how to create multiple subnets when given a specific network or subnet. So you'll be able to answer questions like, subnet this network into at least 10 subnets, or subnet this network into subnets each having 10 hosts on them. So in part 1, you're going to be given an IP address, and then you're going to need to learn how to work out the subnet address, first host address, last host address, and the broadcast address. And we're going to use two methods, the binary method and the quick method. And as I mentioned, I suggest that you choose one of the two methods. Look at both, decide which one you prefer, and then learn and get good at that specific method. So here's a typical example. You've been given a host with an address of 192.168.10.18 with a /24 mask, and you'll need to be able to answer the following questions. What IP address would router 1 be configured with, this router being router 1, if it is to use the first IP address in the same subnet as PC1, which is the PC here. A second question could be, what broadcast address is used by PC1? Or thirdly, what IP address would router 1 be configured with if it is to use the last IP address in the same subnet as PC1? So the first question was, what IP address would the router use if it's configured with the first IP address? And the third one is, what IP address would it be configured with if it were configured with the last IP address in the subnet? And fourthly, a question could be, what subnet is PC1 part of? So you should, within 30 to 60 seconds, be able to answer those questions. And I'm going to show you how to do that now. So the first method is to use binary to work out the answers. I personally prefer binary because it's used all over the place in networking. And once you get your head around how binary works, it will save you a lot of time in the long run. Please refer to the binary section of this course if you're not sure about the basics of binary. We are going to assume knowledge of binary now. We're just going to use binary to work out the answers to those questions. In the binary method, you need to remember 4 rules. To work out the network or subnet address, you fill the host portion of the address with binary zeros. So you work out which part is network and which part is host, and you fill the host portion with binary zeros. To work out the broadcast address, you fill the host portion of the address with binary ones. To work out the first host in a subnet, you fill the host portion of the address with binary zeros except for the very last bit, which you set to a binary 1. And to work out the last host in the subnet, you fill the host portion of the address with binary 1s except for the last bit, which you set to binary 0. If you remember those 4 rules, you'll be able to work out the answer to any of those questions very quickly. So let's start with a basic example. We have a PC with an IP address of 192.168.1.18/24, or it could be written as 192.168.1.18 with a mask of 255.255.255.0. As you learnt in the IP addressing section, these two are equivalent subnet masks. It's very similar to saying tomato or tomato, or router or router. It means the same thing. It's just a different way of displaying the subnet mask. Now hopefully you remember that 24 means 24 bits in the subnet mask. In other words, we have 8 bits in the first octet, 8 bits in the second octet, and 8 bits in the third octet. That means the first 3 octets are network. So 192.168.1 is the network portion of the address, and this last octet is the host portion. And that's how I've written it here. The first 3 octets are displayed in black, representing the network portion, and the last octet is shown in red, which represents the host portion of the address. There's no point converting the network portion into binary, so I've just left it as it is. So the subnet is equal to 192.168.1 dot, and if you remember back to our rules, to get the subnet, you fill the host portion of the address with binary zeros. So this is a single octet, so 8 binary zeros need to fill that host portion. If you convert 8 binary zeros back into decimal, you'll get the value 0. So the subnet is 192.168.1.0 for this specific IP address. To get the first host in the subnet, you fill the host portion of the address with binary zeros except for the last bit, which you make binary 1. So an octet once again is 8 bits. So there are 7 binary zeros followed by a single binary 1. Converting that back to decimal, you get 1. So the first host in this subnet is 192.168.1.1. To work out the last host, fill the host portion of the address with binary 1s except for the last bit you set to binary 0. So that's 7 binary 1s followed by a binary 0. If you convert that back to decimal, you'll get the value 254. So the very last host in this subnet is 192.168.1.254. To get the broadcast address, fill the host portion of the address with binary 1s. So a single octet full with binary 1s is equal to 255 in decimal. So there you have it. We can work out the subnet, the first host, the last host, and the broadcast address very quickly and easily using the binary method. So if you were asked to configure the first IP address in the same subnet as PC1 on the router's interface, you would know that you need to configure the IP address 192.168.1.1/24 or 192.168.1.1 255.255.255.0. You could be expected to type the commands onto the router to configure it with the relevant IP address. Later in this course you'll learn the commands to do that, but for now realize that you might need to work out first, last, broadcast and subnet addresses when given a specific IP address. This was our first example using the binary method. I'd like to show you a more complicated example now. So in this example you've been given an IP address of 172.16.35.123/20, or in other words 255.255.240.0. This is a little bit more complicated because the mask does not fall on the octet boundary. In other words, it's not a simple /8 or /16 or /24 subnet. The network and host portion lies somewhere in the third octet. So just to reiterate, /20 means that there are 20 bits of the 32-bit IP address which are used for the network or subnet portion, and the remaining 12 bits are used as the host portion of the address. So somewhere in the third octet, the network host portion changes. So once again, our IP address is 172.16.35.123/20. Now the first octet is 8 bits in size. The second octet is 8 bits in size. So adding those together you get 16 bits. The third octet is 8 bits in size. So adding those three together gives you 24 bits. So /20 in the subnet mask means that the split between subnet and host occurs somewhere in the third octet. So once again, the first octet is 8 bits, second octet is 8 bits, thus 20 bits puts the split somewhere in the third octet. So what you need to do is convert the third and fourth octet into binary because they both have host bits. There's no need to convert the first two octets into binary because no host bits are found in the first two octets. So 0010, 0011 is the binary equivalent of decimal 35. 0 followed by 4 binary 1s, followed by 0, followed by 2 binary 1s is the binary equivalent of decimal 123. So all we've done is convert 35 and 123 into their binary equivalents. Please see the binary section of this course if you're not sure how to convert decimal into binary and back again. 20 bits of subnet mask puts us in this position because we have 8 bits plus 8 bits in the first two octets, which gives us a total of 16 binary bits. Plus 1 is 17, plus 1 is 18, plus 1 is 19, plus 1 is 20. So we can draw a line at this point to split the network and host portion. To the left of this line, the binary bits indicate network or subnet. To the right of this line, the binary bits indicate host. So there is a split between network and host portions in this address at this line. So to work out the answers, you need to remember our 4 rules. The first rule states that to work out the network or subnet address, you need to fill the host portion of the address with binary zeros. So to the right of the line, we need to fill this entire portion of the address with binary zeros. So once again, 20 bits of subnet mask puts us in this position, and we fill everything to the right with binary zeros. So we end up having 172.16. The first 4 bits of the third octet remain the same, and all remaining bits are set to binary 0. When you convert that back to decimal, please note firstly that these 4 bits in red plus the following 4 bits in green are part of the third octet. So 0010 followed by 4 zeros, when converted from binary to decimal, give us a value of 32. The fourth octet is filled with zeros, so converting an octet filled with binary zeros to decimal gives us a value of 0. So the subnet address is 172.16.32.0. Now to work out the first host address, fill the host portion of the address with binary zeros except for the last bit, which is set to binary 1. So here you go. The first host is equal to 172.16.0010. Remember, we don't touch this portion of the address. We only change the host portion of the address. So we fill the host portion with binary zeros except for the last bit, which we set to binary 1. Once again, the third octet consists of 4 binary bits, which are part of the network or subnet, and 4 binary bits, which are part of the host portion. Those 4 red binary bits, together with those 4 green binary bits, give us a decimal value of 32. The last octet is 7 binary zeros, followed by a single binary 1, which is equal to decimal 1. So the first host address is 172.16.32.1. To work out the last host address, fill the host portion of the address with binary 1s, except for the last bit, which is set to a binary 0. So the last host is equal to 172.16.0010, followed by 4 binary 1s in the third octet, followed by 7 binary 1s in the fourth octet, and then lastly a binary 0. So the third octet consists of these 4 red bits and these 4 green bits. So if you convert 0010 followed by 4 ones into decimal, you'll get the decimal equivalent, which is 47. 7 binary 1s followed by a binary 0 gives you the equivalent decimal value of 254. So the last host in this subnet is 172.16.47.254. To work out the broadcast address, fill the host portion of the address with binary 1s. So the broadcast address is equal to 172.16.0010. Once again, the network and subnet portion are left as is, and then you fill the host portion with binary 1s. So the third octet is equal to 0010 and 4 binary 1s, which once again gives you the decimal equivalent of 47. 8 binary 1s in an octet gives you the decimal value 255. So the broadcast address would be 172.16.47.255. So in summary, an address of 172.16.35.123 with a subnet mask of /20 resides on subnet 172.16.32.0 and has a broadcast address of 172.16.47.255. The first host in the same subnet is 172.16.32.1 and the last host in the same subnet is 172.16.47.254. This was a slightly more complicated example, but I'm hoping that by now you have learned the process to work out subnet, first host, last host, and broadcast address when given an IP address and its subnet mask.